live. Okay, okay, okay. Thank you. Sir, sorry, there was some delay from my end. So if you please let me know if you can hear me. Okay, some issue happened. Yes, yes. Hi, Sumit. Hi, Pooja. Hi, Manikanta. Yes. Sorry, there was some minor issues. Actually, we are not used to do live streaming in the morning, right? We are mostly doing live streaming in the evening, afternoon, right? So there was some issue from our technical team, so they are not they have not connected this stream with the live. I was live. I was talking over here, but somehow the stream was not reaching it because it was not showing live. Hi everyone. So let's start with today's chapter, electric charges and fields. So I have completed only one chapter in the Masterstroke. Masterstroke is basically where we are doing one shot classes. After the class is over, whoever gets a chance, they will start solving questions in the live session. Okay, so I will be solving 20 questions in the live session, and 20 questions, they are not simple MCQs, they are KCET level MCQs. So there will be some tricks, tips and calculations involved. Also some MCQs I have picked from previous year questions which I felt important, and some questions are taken out of the previous year question as well, which in my opinion can come in your KCET exam. Okay, so let's without any delay, let's start with the question that came in 2024. So also you will get this new feature. So you will get what is the level of difficulty, how much time you should spend to answer such questions, okay, and what is the level of the question. So everything will be provided to you, and you will get an idea that when solving easy question, how much time you should spend, and when solving slightly difficult question, can you invest more than the time allotted. Okay, so right, so let's start. Yes. Hi everyone. So solve this question, easy question. The total electric flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is given. Epsilon naught is the permittivity of the free space. Easy question, you should easily answer this question, and whenever you answer the question, I will take few answers. I will also mention the question number. So suppose question number 1 has correct option D. So you have to mention question number 1 option D. So 1D, you should answer like this. This is the format that we use. Okay, 1C, Pooja is saying 1C, Rohit is saying A. Rohit 1A, mention 1A like Pooja has mentioned. Okay, future engineers, hi. Pratiksha, yes everyone, hi, good morning. So you have to mention the P is equal to 2aq. Yes, P is equal to 2aq, that is fine, but what is the electric flux? What is the electric flux? They have given it for a electric dipole. Okay, electric dipole means it has a positive charge, it has a negative, equal and opposite negative charge, and entire thing is enclosed in a surface of radius r. Okay, now so we know that electric flux depends only on the charge which is enclosed by the surface. The total charge here, total enclosed charge here is plus q minus q, that is 0. So enclosed charge 0 means flux is 0. So this is a very easy but yet conceptual question, and you should not spend more than 10 to 15 seconds to answer such question. Just to read the question, as soon as you read, you have to I understand that this is an electric dipole. So electric dipole has total charge 0. So total charge 0 means electric flux will be 0. Now let's move on to the next question. Okay, this is a slightly longer question. Here you can take about 25 to 30 seconds. A point charge A of charge plus 4 microcoulomb, another point charge B of charge minus 1 microcoulomb are placed in air at a distance 1 meter apart. Then the distance of the point on the line joining the charges and from the charge B where the resultant electric field is 0. So when you are, obviously right now you can take slightly more time. When you are expert in this, when you have solved a lot of questions, when you are ready for your KCET exam, So at that point of time you can only spend 25 to 30 seconds to solve this question. Okay, so I will teach you how to do that. So this is 4, okay, this is 1 microcoulomb, both have the same charges. So don't worry, you don't need to use the microcoulomb in this case, because basically we will find the electric field which will be equal to each other. So that means we do not need to consider about the magnitude. This is the shortcut method. We are not doing the proper thing using all the units has to be correct, all the conversion has to be correct. You can take some liberty. So suppose because it is a charge, so suppose this is the distance from where from the charge B, right? So from the charge B, suppose this is x, so this is charge A, this is charge B. Okay, from the charge A, from the charge B, say the distance is x, you have to find where they are 0. Okay, what is the given distance? One meter distance. Original distance is 1 meter, right? Now solve it quickly, then I will solve. 2c 2c 2c, let's see. Yes, 1 meter. Thank you. So 1 meter is the distance. Now so what we will do, this distance is x, that means the other distance is 1 minus x. So 4 by 1 minus x whole square equals to 1 by x square. This is a shortcut method. So electric field due to this charge should be equals to electric field due to the other charge. Now electric field is kq by r square. Now k is constant, so they will cancel each other. So this is the shortcut way to solve this question. Now you have to take the square root on both sides. If you take the square root, you can write 2 by 1 minus x equals to 1 by x. Okay. So now you have to improve your mathematical calculation ability. If you are not doing so, it is 1 minus x. Okay. So this will come this side. So 3x equals to 1 or x equals to 1/3. So this is the answer. Not super difficult. So 1/3. Have I made any mistake? Okay, there is a mistake that I made. What is that mistake is that, so this was a +4 and the other charge was -1. Okay, so there will be no point between the charges where the electric field will be 0. Why? Because if you consider any point here, the electric field will be in this direction due to this charge. Similarly, due to negative charge will be also in the same direction. So it has to be somewhere outside the charge line. Okay, it has to be somewhere outside the charge line. So this is the x. Okay, so the second distance will be 1 plus x, not 1 minus x. Okay, so suppose this is the point where we are saying that electric field is 0. So actually my mistake was this negative sign I missed. Okay, so it will be minus 1 microcoulomb. So now let's see the equation again. 4 by 1 plus same strategy is same, only thing I made a small mistake. Okay, so 4 by 1 plus x square equals to 1 by x square. Now take the square root of both sides. It will be 2 by 1 plus x equals to 1 by x, or it will be 2x equals to 1 plus x. Again I made some mistake here. First we must calculate the external after internal. Yes, positions are wrong. Positions are wrong because obviously no, answer 1 is not possible. If it is okay, x can be 1 meter, right? Yes, x can be 1 meter. X is the extra distance, right? X is the extra distance, not the distance between the charges. Okay, fine. So it is x equals to 1. Yes, positions was wrong because there will be no point between the charges where the electric field will be 0, because you have to understand the fact that when one is positive, another one is negative, between the charges electric field will always point in the same direction. Okay, so they will not cancel each other. But if you consider any external point, okay, in that case it will be away from due to this charge, whereas due to negative charge it will be towards, so they can cancel each other. But if you are considering what should I say, in between points, the electric field will point only in the one direction. Okay, so this is the way to solve. Okay, there is a shortcut way later on in maybe in future while solving questions I will show you the answer. Sir, yes, minus 1 is 1 minus x. No, not minus 1. It will be 1 minus 1 will be only x. Minus 1 will be only x. We are trying to calculate x from the charge B, right? This is the charge B, this is charge A. Okay, and we are trying to find the distance from 1. Why this is x? This is x because we are told find the distance from the charge B. Find the distance from charge B. So charge B is minus 1. Okay, and we said that at a distance x from minus 1 itself is the electric field is 0. So now the electric field from due to this charge and due to this charge, they are opposite to each other and they can cancel each other. Now you can similarly find 0 position here as well. Okay, here somewhere on the left hand side also, suppose this distance is y. Now this is your task, homework maybe. You can find where the electric field, what is the distance for y, that where this electric field will be 0. Y will be greater than that of x. Okay, y will be greater than that of x. You have to calculate. Okay, you can calculate and you can tell me the answer later on. Okay, but you have to remember that, and it is maybe y is not super simple to solve anyway. Okay, it might give you complex roots, but anyway you have to be careful that when you are solving, this is the distance. So due to this is charge divided by r square, and due to this is charge divided by entire distance 1 plus x whole square. This is not 1 plus x, this is 1 minus, neither 1 minus x, neither 1 plus x, this will be directly x. Okay, so 4 by 1 plus x whole square is equal to 1 by x whole square. Now the steps is simple, is equal to 1. Sir, please provide PDFs of class notes, KPL and other series. KPL and other series is already uploaded, Hanan, but we will share the links again. And one more thing, this class notes will be available. I will ask our coordinator to upload as soon as possible. You will be shared with the drive link. There all the class notes after every lecture will be updated automatically. You can find it there. Okay, now let's see question number next question number 3. Two highly polished charged copper sphere have radii in the ratio 1:2. Okay, this is even though it is mentioned easy, it is not easy, it is a medium level question. To highly polished charged copper sphere have radii in the ratio 1:2. The sum of charges on them is 75 microcoulomb. The electrostatic force between them when they are brought in contact and then placed 3 meter apart is. Okay, now in this case, if it was a potential related question, okay, then this ratio would have mattered. Okay, because there is no point, they are the center, the distance between the centers is 3 meters, I guess. Okay, they are brought in contact and then placed 3 meter apart, means distance between the centers. Definitely radius should not play any role, even though one is bigger, one is smaller. Okay, it only depends on the charges, right? So they have said the force. So whenever they are kept at a distance like this, okay, radius is not important in this case. If they ask you what is the potential on the surface of the bigger sphere, then in that case radius is important. okay, but otherwise the radius is not important, because whenever you are considering some point here, okay, as external points, all the external points, you can consider the entire charge of the sphere is located at the center of the sphere. Okay, so basically what is that? This is basically a simple Coulomb's law, okay, not electric flask, this is wrong, it will be Coulomb's law based question. Okay, sir, then 0.5 should be answer, because by the way, unlike charges, null point lies inside the distance between them. Unlike charges, distance cannot be between them. Okay, if they are like charges, then the distance is between them. Okay, if it is unlike charges, you have to, it is not, we are trying to find the, not the potential, be careful, it is not the about potential, it is electric field. Potential lies between them, okay, but electric field will lies outside. Electric, you are confusing between electric potential and electric field. Okay, if the charges are unlike, yes, if the charges are unlike, then what you have done, I guess, is 4 by 1 plus 1 minus x is equal to 1 by x. That's how maybe you have solved. But here you have to remember that the charges are one is plus, one is minus. So what is the direction of electric field at this point? Suppose in between some point, what is the direction? So if you put a positive charge, unit positive test charge here, that test charge will be attracted towards this, right, and it will be repelled by this positive charge. So both cases, it is experiencing force in the same direction. So how can there be a null point between them? Okay, if you are talking about potential, that is different. Okay, here we are talking about not even if you are talking about what should I say, if you are talking about some force on some charge kept in between, that will be different. Okay, but if you are talking about electric field, it will not be zero between them. Okay, electric field will be in the same direction for both positive charge and negative charge, they will be in the same direction, so they cannot cancel each other. To cancel each other, there has to be some external point. If it is a potential, yes, potential will be in between them. Okay, potential 1, due to positive charge it will be positive, due to negative charge it will be negative. You can simply equate them and find the answer. Okay, it was not about electric potential, it is talking about electric field. Okay, right. Hanan, what is the step-by-step process to master a chapter in physics with respect to this channel? Someone already solved 3A. Let's see. Anyway, the process is, first of all, if you are depends on what is your goal. If you are currently studying in second PU, also you are studying for KCET. So first you have to check our Masterstroke. We have started this Masterstroke series. You can check all the concepts, relevant concepts from this Masterstroke series, and then you can attempt this problem solving for your KCET preparation. For your PU board preparation, there is another series called Brahmastra series, where we have done entire PU coverage. Also, if you right now you don't have the time to do with the complete detailed chapter study, where the study hour is long. Okay, and it was a KCET 60 out of 60 that we started at the beginning of the year. That was a 1-year program, but maybe you have missed some of the lectures. You can practice questions from KPL. We have done KPL series. There we have given a lot of questions chapter wise. Okay, you can practice questions as soon as you complete the chapter from there. Now let's see. So first we have to understand that whenever you touch the two charges, okay, here the thing is, charges are not getting divided equally. That is the main thing. Okay, so this is this requires some knowledge of electric potential. So what is happening? They will exchange the charges. The radius comes into the picture in the first part. Radius is not important in the second part. So suppose the radius for the first part is 1 and the second one is 2. Okay, how the charge is getting distributed between them, that is very, very important. So if this gets a charge, say Q1, and this one gets a charge, say Q2, so the total charge will be Q1 plus Q2, that is equals to 75. Now what is Q1? So Q1 and Q2 are distributed such that the potential of this surface is equal to potential of the other surface. Okay. So charges are distributed till they acquire the same potential, right. So some knowledge of potential is required to solve this question. So V is equal to KQ by KQ1 by R1, that is say 1, and that should be equals to KQ2 by R2, that is 2. Okay, so here from there you can find the relationship between Q1 and Q2, that is Q1 is basically Q2 by 2. Okay, now you have to put it here. So Q1 plus Q2 equals to 75, and Q2 by 2 plus Q2 is 75, or 3 Q2 by 2 equals to 75. So it will be cancelled, 25. So Q2 is basically 50. Okay, so Q2 is 50 means Q1 is 25. Rest is easy, right. Now we have calculated the charges. Okay, this is microcoulomb. Micro means 10 to the power of minus 6. This is 10 to the power of minus 6. So this part you have to solve quickly, and this is very typical. This kind of questions does not come in PU board. This is a KCET special question. Okay, it will never come in PU board exam. Okay, not even in your dreams, because this is a slightly mixed concept question. Even though it requires a knowledge of potential knowledge is easy, and in case you need some more explanation for this problem, please let me know in the comment below. Sir, I did not understand, then I can explain it once more. This is a very typical KCET question. Okay, now this is the also those who may be preparing for NEET exam. This type of question comes in NEET exam as well, not in JEE super common, not super common in JEE, but NEET exam as well. So Q2 and Q1 we have calculated. Now what is the force? Force is K Q1 Q2 by R square, obviously Coulomb's law. K is 9 into 10 to the power of 9. Q1 is 50 into 10 to the power of minus 6. Q2 I have written first. Let me write Q1 second. 10 to the power of minus 6 divided by 3 square. Okay. Now we have to simplify. And try not to use calculators while solving problems. Okay, now this 3 square and this 9 will cancel. Okay, I don't want to write it again that this will be a 9. So what we can do, you can save some time. So now if you see, there will be 50 into 25 and 10 to the power of 9 and 10 to the power of minus 12. So 50 into 25 into 10 to the power of minus 3. Why minus 3? Minus 12 plus 9 minus 3. Okay, 5 25s are 125, 125, 0 into 10 to the power of minus 3. So it will be 1.25 Newton. Okay, correct answer is option A. Okay, I think someone answered. Yes, 3A, yes, hi. Kirti, yes, okay, correct. Wanna study, yes. Creative, no, not D is the not answer. Okay, it will be A only. Okay, it will be A only, 2.25 Newton. 5 into 25 is 125. Okay, 4 into 25, how to remember this kind of thing? 4 into 25 is 100. Okay, 4 into 25 is 100, 5 into 25 will be 125. Okay, 6 will be 150, 7 will be 175, 8 will be 200, 9 into 25 will be 225. Okay, right. Now let's move on to the next question. If the charge on the body is plus 1 nanocoulomb, then how many electrons are removed from the body? Easy question. So we know that you can use the fact that Q is equal to NE. Okay, this is an easy question. Conceptually, quantization of charge is involved. Q is given 1 nanocoulomb. 1 nanocoulomb means 10 to the power of minus 9. Okay, N we don't know. E is 1.6 into 10 to the power of minus 19. Okay. So, n equals to 1 by 1.6 into 10 to the power of 10. Okay. This kind of things you have to practice. You might be thinking how sir is doing it, because I am doing it because I have done the practice. So, it will be 0.625 into 10 to the power of 10. Now, if you check the answer, it will be 6.25 into 10 to the power of 9. Okay. So, this is one of the way, or you can remember that 1 coulomb charge, if you convert 1 coulomb charge, okay, the number corresponds to 6.25 into 10 to the power of 18. How much charge is given here? 1 nanocoulomb. So, you have to multiply with 1 nanocoulomb. So, that is 1 into 10 to the power. If you multiply with, this is for 1 coulomb charge, for 1 nanocoulomb charge, if you multiply it, you get the answer directly. That will be 6.25 into 10 to the power of 9. This is for slightly higher order level if you have practiced it, but you have, if you remember that for 1 coulomb charge, the corresponding number is 6.25 into 10 to the power 18. Then whatever other charge is given to you, if you multiply it, you can directly get it. That is the shortcut way to solve it. Otherwise, this is slightly longer, maybe 10 seconds longer, but this is also fine. Okay, if you are good in analytical calculations, you can use the second methods as well, but be careful. Why? What should be the thing you need to be careful about is the 10 to the power. Okay, other values are already given same. Now, next question, question number 5. This is a mixed question, slightly medium level question. The force between the electron in the first Bohr orbit and the nucleus. So, again even though we have not dealt the chapter yet in the KCET, but we have to be so 5A was the answer. Yes, 5A was the answer, 4A was the answer, sorry. Yes. Okay, now whatever I will give you, if possible, if it is available, I will give you more than one method to solve one question. Okay, and this is a we will be solving quickly. The force between the electron in the first Bohr orbit and the nucleus in the hydrogen atom is F. Okay, the electron jumps to the third orbit, the force between the electron and the nucleus will be. Okay, it is slightly conceptual, otherwise easy question. Okay, I mentioned it is medium, but in my opinion this is slightly easy question. Only thing you have to remember the formula for Bohr orbit, that's it. Okay, so let me solve it. I will give you 1 minute to answer. Hanan, please give the synopsis too. Synopsis we will give, synopsis is very short. Okay, synopsis we will give after PU exam is over. That will be like maybe 20 minutes. Only the just gist of the chapter. Okay, that will not help you if you have not completed the chapter. So that's why if you have not completed the chapter, you have to follow the series right now. Okay, gist we will give just before the exam. Don't worry. Okay, now what is the radius? Bohr radius. What is the relation? Rn equals to R0 divided by n square, right? This is the Bohr's radius, that you have to remember. Now, initially the force between nucleus and the electron in the first Bohr radius is given by F. So, F is basically equals to K Q1 Q2. We do not know what is the charge of the nucleus, what is the charge of the electron. So, we are not interested in that. Only thing that we are interested is this factor. So, this is the first case when the orbit, when it is in the first Bohr orbit. First Bohr orbit means n equals to 1. Now, when it moves to the third Bohr orbit, then R3 will be R0 divided by 3 square. So, it will be R0 by 9. Okay, R0 by 9. So, now what will be the force? The new force F dash will be K Q1 Q2 by R0 by 9 whole square. So, many students will try to solve it and they will answer maybe this one. Sorry, I have done one something wrong. It is not R0 by n square, it is n square R0. Hi Tarun. Hey guys, stop discussing, start solving the question. Here I am trying to solve the question and you guys are wasting your time, which is not cool. So it will be 9 R naught. So R3 will be 9 R naught whole square. So it will be F will be equals to F by 81. So it will be F by 81 is the answer. So F by 81. So as it moves from first Bohr orbit to third Bohr orbit, the force becomes very less. So it will be F by 81. Right? Now next question. Two small spheres each having the charge plus q are separated by are suspended by insulating threads of length L from a hook. This arrangement is taken to space where there is no gravitational effect. Then the angle between the two suspensions and the tension in the each will be. So this is a live session. Okay, please try to solve it. So we have two wires length L, okay, each having charge plus q. So this is plus q, this is plus q, okay. Now there is no gravitational field, everything is balanced by this tension. So this is the, there is a tension here, okay, there is a force here, there is a force here, okay. Force, this is electrostatic force, this is also electrostatic force. Now generally what happens is that when it is in the gravitational field, there is a component mg over here and that component mg actually balances everything. So three forces, one component of t along this, if this is theta then it is t cos theta, t cos theta is here, t sin theta is up, they balance each other, okay. But in this case the problem is with this problem, not this problem, the trick you can say, this is not a problem, this is the trick, that there is no mg present here, there is no mg present here. If there is no mg present, then what will happen? If there is no mg present, then what will be the angle? Short shear is saying 6c. Let's see. So because there is no mg present, they instead of getting balanced like this, they can only have a balance when they are completely stretched, right. So whatever force is there, suppose the force is here F, Coulomb force, okay, the same force has to be balanced by the tension, same force has to be balanced by the tension. The angle will be definitely 180 degrees, no other angle is possible. Also in the option also, if you see, three of them are 180 degrees, so definitely 180 degree will be the answer. 90 degrees not possible, no other angle is possible here, no other angle is possible here, okay. They can only stay in equilibrium when they are completely stretched. Now this force and the tension, actually the tension will be equals to the Coulomb force, that is 1 by 4 pi epsilon naught, that is K, Q1 Q2, Q1 is Q, Q2 is also Q, divided by this is L, this is L, okay. So it will be 2L whole square. So it will be Q square by 2L whole square, Q square by 2L whole square, okay. So not C. So the mistake you made is you made 2L square. So if you see, there is a trick here, 2L square is here, 2L whole square is given here. So you have to be careful, don't rush. That's why I always say read the question, read the option, then only you can answer. Someone answered 6C, so it is not 6C, it is 6A. Yes, future answered it correctly, future was correct. So it will be 6A, not 6C, okay. So be careful, the trick is not maybe you will think, okay, 2L square, so it will be the C option. So when solving, you have to stay calm in your head. That is why we will be solving this question. We are doing the solution in this series, right. Now another easy question: the angle between the dipole moment and the electric field at any point on the equatorial plane. So dipole moment and electric field on the equatorial plane. So this is the equatorial plane. This I have just drawn the two-dimensional thing. Easy question. I will take one answer. Easy question 7. First answer, 2 minutes quickly. And this is like not even 20-30 seconds. This is a 10-second question. 10 seconds. Read it, answer it. Read the question and answer it. 7D. Shravya is saying 7D. Why Shravya 7D? Why Shravya? So they have asked you to find the electric field and the dipole moment. So electric field due to a, suppose this is positive, this is negative. Okay, the electric field will be in the positive x direction and the dipole moment will be in the negative x direction. Okay, it is from negative to positive, and if you have solved it, you remember that we take component like this, and they give you the final addition is along x direction. So basically electric field is in this direction and dipole moment is in this direction. Okay, so the angle will be definitely only 180 degrees. Okay, so this is simple question. You have to remember this kind of question is common in PU also, slightly very common in PU. The language is slightly simpler, but it can come in PU as well. Now let's see question number 8. Two charged spheres separated at a distance d exert a force F on each other. If they are immersed in a liquid of dielectric constant 2, then what is the force if all conditions are same? So initially we have two charges, okay, say Q1, Q2 separated by a distance. Now if the force between them is at this condition is F, when you immerse it into the a fluid of say a dielectric constant 2, then what will be the new force between them? Many answered it correctly. 7A, 7A, short shear, Pooja, Shravya. Now future saying 8A. Let's see. So there is a shortcut way. What is the shortcut way? You can do the mathematics for all the, there is a formula etc. available, but I don't want to use the formula. This is a simple case. So we know that force between two charges is given by 1 by 4 pi epsilon naught Q1 Q2 by d square. This is the first case. Now when you immerse the entire thing into the liquid, only one quantity changes. That quantity is this epsilon naught. This is no longer epsilon naught. So this epsilon naught is only when it is kept in air or in vacuum. Okay, but if you keep it in some other medium of dielectric constant K, then what you have to do, the new force will be 1 by 4 pi epsilon into Q1 Q2 by d. Now what is d square? What is epsilon? Epsilon is basically k into epsilon naught. So this is k into epsilon naught, right? So it will be you can just simply what you can say that okay, if I immerse the entire system into a liquid of dielectric constant K, then the new force will be F by K. So here in this case F by 2. Now if you remember this problem, solution to this question, okay, if the similar question comes with a different dielectric constant, you will immediately know just we have to divide it by 2. That's why we are doing the solution, and this final result you can remember it as a shortcut way to solve questions. Okay, there are hundreds of problems, there will be 100 different types of shortcuts and tricks. You cannot remember all of them, but try to remember at least few of them, whichever is helping you to solve questions quickly. A charge Q is placed at each opposite corners of a square. A charge small q is placed at each of the other two corners. If the net electrical force on capital Q is 0, then capital Q by small q equals. So let me draw the question first. We have a square, okay, we have a square, okay, two corners we have capital Q. So here we have capital Q, here also we have capital Q, and the other corners we have small q. Okay, the net force on this charge is 0. Net force on this charge is 0. So how what is the net force? First of all, you have to remember that what will be the these two charges are same, right? These two charges are same means it can only repel it. It can only repel in the diagonal direction. So if this is a repulsive force, okay, then it can be only balanced if there is an attractive force in this direction. But attractive force in this direction means how can that be happen? That can only happen if this is attracting in this direction and this one is attracting in this direction. So if Q is positive, then small q has to be negative, and vice versa. We are not interested in exact sign. But when we are trying to find the ratio, that means ratio has to be negative. Ratio cannot be positive. Okay, ratio has to be negative. Now the net force is 0. Net force is 0 means if this force is say F1, okay, F1, this force say F, this is also F. This F means in this direction the force will be, due to this component will be F root 2, and due to this will be another F root 2, right. This angle is 45 degrees, right. Sorry, F by root 2 plus F by root 2. So total sum will be F root 2. The sum will be F root 2. Okay, this will be F by root 2. This will also be F by root 2. Okay, you can take cos component or sin component. In both cases, you will get F by root 2 plus F by root 2. So it will be 2F by root 2. So it is F by F root 2. So you have to remember, when two equal vectors are perpendicular, their resultant is basically F root 2. That is the thing that you have to remember. It will be helpful to solve this kind of questions, not only here in vector additions, in other parts also. Okay, this type of questions are very common in competitive type of exams. Okay, they will be giving you two vectors where you have to calculate that they are, basically you have to show that they are perpendicular. So F root 2 has to be equal to F1. So F root 2 has to be equals to F1. Now we have found out that they are opposite in sign. So what is F? First of all, F is the force between these two charges, right. So Q minus Q, capital Q, okay, divided by the distance. The distance is L, say L square. That should be equals to these two forces. Okay, so that will be Q into Q divided by, what is the distance? The distance will be root 2 L. Diagonal, right, diagonal is root 2L. Now here we have a root 2 here. Now let's cancel, Q cancels. Okay, now we will get minus Q root 2 by L square equals to Q by 2 L square. So L square also cancels. So we can say that Q by Q is minus 2 root 2. Okay, this answer is option A. 8A, F by K. Yes, F by K, obviously F by K was the answer for the last question. Yes, 8A. All of you have answered it correctly. 8A, correct. Okay, this is a common question. This type of question, this one question is solved in your textbook, but you have to remember that you cannot just simply remember the answer for a question. You have to apply based on the question given. Okay, now next question, question number 10. Dipole with dipole moment 4 into 10 to the power of minus 9 coulomb meter is aligned at 30 degree with the direction. This is a KCET 2022 question. Okay, so this is a KCET question. So and electric dipole with dipole moment 4 into 10 to the power of minus 9 coulomb meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 to the power of 4 Newton per coulomb. The magnitude of the torque acting on the dipole is. Easy question. Okay, so what is the torque? Magnitude, torque's magnitude is Pe cos theta, right. Torque is P sin theta. torque is vector quantity, so it has to be cross product of P and E, P cross E. So P cross E means it is PE sin theta, not cos theta. Okay, so P is given by dipole moment is 4 into 10 to the power of 9. Actually guys, I am slightly running late on time, so that's why I am trying to solve more questions myself without giving you too much time. But next question I will give you some longer time. Okay, it is an easy question, you can solve it if you just know how to solve it. Okay, so 20 into 10 to the power of minus 5 and sin 30 means 1 by 2. So it will be 10 into 10 to the power of minus 5, or it will be 10 to the power of minus 4. Okay, so the answer is option B. Okay, if you have solved it, 10B, Aziz no, 10B is the answer, not 10A. So the tricky part for this problem is only one thing, is because it is 10 into 10 to the power of minus 5, you have to reduce 1 10 to the power to match the correct answer. 10 to the power, it is only giving you 10 to the power of minus 5, but there is a 10 multiplied with it, so that's why it will be option B, not option A. Okay, that is the only tricky part, otherwise very simple, easy question. Next question, two charges 4q, I will give you to solve this problem, I will give you some time. Two charges 4q and q are 3x apart in air. So 2q and q are separated by a distance 3x. Okay, a charge capital Q placed at a point on the line joining so that the system of these three charges remains in equilibrium. Then the distance of capital Q from 4q and the value of capital Q are. So this is a slightly longer question. So it is placed, say, at a distance 3x. Okay, now you placed 4q and q, sorry, 4q and q, right, not 2q. 4q and q are 3x apart. Suppose I placed a capital Q charge here. Okay, I placed a capital Q charge here. Now this is, the system is in equilibrium. What is the meaning of that? System is in equilibrium means whatever force is being acting on between these two charges, these three charges, all the forces, first of all the forces on capital Q are 0, all the forces on small 4q are 0, all the forces on q is also 0. That means, that is why, that is the meaning of all three charges are in equilibrium. If I say only capital Q is in equilibrium, that means all the forces only in capital Q are 0. But if I say all the forces are in equilibrium, that means all forces on individual charges are 0. Okay, you can have some time to solve it. Let's see. Shravya, thank you, I corrected it. Ha 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 is saying C. Ha ha ha, you mention the, you have to mention the question number. Okay, so ha ha is saying question C. So let's see who is correct. I don't know the answer, I have to solve it to find the answer myself. Okay, so 4q capital Q. So this is say the distance from the 4q is, say, x, not x, x is already given, so we cannot assume this is x. Say this distance is d. Okay, the total distance between the charges is 3x. So obviously, first thing first, we have to first consider the equilibrium of the charge q. That will give us a lot of hint. Now if this is plus, this charge is plus, nothing is written here, right? So both of them are plus. Now what will be the sign of this charge? Can it be negative? Can it be positive? Yes, it can be positive, it can be negative, because both charges are positive. That means if it is positive, then both will be repelled in the same, opposite direction. So that is also possible. If this is negative, both will be getting attracted. But what about the other equilibrium of the other two charges? That is very, very important. Okay, that is very, very important to determine the sign of q. Okay. So, if this charge was positive, if capital Q was positive, then it will be repelling this charge, and this charge will, this small q charge will also repel it. So, both charges will actually force it to move out. So, in that case you will not get any equilibrium. So, that means that capital Q has to be negative. Only that way what is possible is that this capital Q will attract this charge and this small q will repel this charge, and they will be in the balance. Similarly, this capital Q will attract this small q charge and this 4q will repel this charge. So, they can balance each other. So, in between only the equilibrium of the charge, it can be positive, it can be negative, both is fine. But if you consider the equilibrium of the entire system, then capital Q has to be negative. Okay. So, if you have thought that okay, option D having only positive charge, that means you cannot do the logical thinking part and you cannot answer it like that. Okay. So, because they have 3 given negative charges. So, one of them will be correct. Let us see. First we will consider the equilibrium of capital Q. So, that is capital Q into 4q divided by d square equals to capital Q into small q divided by 3 minus 3x minus d whole square. Okay. Easy. So, this is the first part done. Okay. Now, capital Q cancels, small q cancels. So, now we have to be careful. So, 4 by d square equals to 1 by 3x minus d whole square. Now, take the square root. We have solved one such question, 2 by d equals to 1 by 3x minus d. Okay. Now, do the cross multiplication. So, we will get 6x minus 2d equals to d, right. So, it will go to other side, 6x equals to 3d. So, that means d equals to 2x. So, we have calculated d equals to 2x. Now, this is also not done because we have 2 options with 2x, right. Either A or B will be the answer. C and D already we have eliminated because charge has to be negative, and we have eliminated C because the distance we have calculated will be 2x, right. Now what? Now what we will do? We have to also find the magnitude for capital Q. Magnitude of capital Q you cannot consider, you cannot find from the midpoint, from the point which is in equilibrium. So, what we have to do, we have to consider another external point, any external extreme charges, okay, either this charge or this charge. Let me consider this charge only, okay, because the distance is d, which is good, okay, and this distance is 3x. So, I will consider this 4q charge. So, we have already calculated that d is basically equals to 2x. Now, what is the equilibrium for this charge? Equilibrium for this charge is 4q into first of all 4q, there are 2 forces, one is due to capital Q, another one is due to small q. So, 4q into small q divided by 3x whole square. This is the force due to small q which is repelling it in the away direction, and another one will be attracting it towards it. So, that will be 4q into q divided by d square. Okay. So, 4q cancels. So, we can calculate capital Q from this. So, capital Q is basically q into d square by 9x square. Now, what is d square? D square is nothing but q into 4x square divided by 9x square. Okay. So, it will be q will be, this is the magnitude of the q, and we have already determined q is negative, q by 9. Okay. So, it will be minus 4q by 9. Now, if you do not have time in the exam and you have only calculated the first part d, then what you can guess is that because they have given one positive, one negative of the same value, so possibly this is the correct answer. This is a way to guess after solving 50%. After solving 50%, you have seen that they have given the same value. So, one is positive, one is negative. That means they are trying to confuse us between whether the charge is positive or negative. So, you can guess, maybe I know 50% of the answer, 2x is the answer, and other 50% I can guess, that will be the other part. Okay, this is a way to use your logical thinking capacity to solve difficult questions, right? Yes, yes, Aziz, Pooja, short share, all are correct. Sir, how do you know question is between them? Question is in between them. It is mentioned in the question. It is mentioned in the question. Q is placed at a point on the line joining so that the system of the three charges remain in equilibrium. Okay, I have taken the point in between. You can try and find if they will be, if you can find a point exist between them, other outside them. So, that is what I said. If the charges are similar, the point has to be between them. Okay, if the charges are opposite, then that will be in the outside. Okay, if one is plus, another one is minus, then the equilibrium point will be outside only. If charges are same, both are plus, then the point will be between them only. Okay, outside the point, okay, even if you keep some positive charge or negative charge, suppose negative charge. Okay, now outside the point you kept a negative charge. Okay, so this will be attracted, this one will also be attracted. So, there will be no equilibrium. Similarly, if you keep a positive charge, this will repel it, this one will also repel it. So, both repulsion means the charge will move away, it will not stay in equilibrium. Equilibrium means what? Equilibrium means it is not moving, it is static, right? That is the meaning of equilibrium. Net force is 0, and if you consider complete equilibrium, net torque is also 0, but since there is no rotational motion involved here, we already know that torque is 0. 2 point charges are 3 meter apart and their sum is 8 microcoulomb. The force of repulsion between them is 0.12 Newton. Charges are simple, but yet a little long. You have to solve this question. I will give you a few minutes to answer. Right. I hope that clears your doubt. So, you have to be mindful about charges are positive or negative. Based on the polarity of the charges, you have to determine whether it will be in between or it will be outside, and it will come with practice. Okay. So, you said no, that sir, how do you determine? It was so embedded into me. I was always thinking both charges are positive, it has to be between them. So, it is back of my mind. I do not have to think, okay, what will, where will the point be. Okay, if you are thinking both charge, one is opposite charges, then it will be outside. You have to practice, and that will be your like subconscious mind should answer those questions. You do not have to think about that. That is the level of practice you need, right? Let's see. 2 point, and for KCET it is easily achievable because question levels are not super difficult. You do not have to solve so many difficult questions. If you solve out of 20, if you solve 5 difficult questions, that is sufficient. Okay, medium questions are more common than super difficult questions. Yes, there will be some super difficult questions, but medium level questions are more common. For example, this is a medium level question, but slightly lengthy. 2 point charges are 3 meters apart and their sum is 8 microcoulomb. So, suppose one charge is one of the charge is x, one charge is x, the other charge is 8 minus x microcoulomb, obviously. Okay, one charge is x, another charge is 8 minus x. Okay, why I am using x? Because it is very familiar if you are using in mathematics. So, I do not want to use q square, it takes some time to write also. The distance is given 3 meters, the force of repulsion is 0.12 Newton. So, what is the force of repulsion? Force of repulsion is K q1 q2 by r square. So, what is K? K is 9 into 10 to the power of 9 into x into 8 minus x, both of them are microcoulomb. So, combined it will be 10 to the power of minus 12. So, that is where student makes mistake in this case. Okay, students will put the values, they understand the question, they understood the value, but they do not convert this microcoulomb into coulombs. That is the problem. Okay, so both of them were microcoulombs. Okay, so you have to convert them into coulomb while solving this question. That is the only trick you have to remember. Now what else? The distance is given by 3, so 3 square is 9, 9 cancels. So we get this force is given by 0.12 Newton. 0.12 can be written as 12 into 10 to the power of minus 3. Okay, here we get x into 8 minus x into 10 to the power of minus 3. So 9 minus 12. You have solved similar questions. So with practice, this kind of questions will become very staple for you. So 8x minus x square equals to 12, or x square minus 8x plus 12 equals to 0. Okay, now you have to divide it. So x square minus 6x minus 2 plus 12 equals to 0, 2x, sorry. So you take x common, x minus 6 minus 2 x minus 6 equals to 0. So x minus 6 into x minus 2 equals to 0. So either x equals to 6 and or x equals to 2. Now the beauty is both charges are 8 microcoulombs. So if x equals to 6, then the other charge will be 8 minus 6, that is 2, and if x equals to 2, then the other charge will be 8 minus 2, that is 6. So the pair is 2 and 6 coulomb. Okay, 2 and 6 coulomb. So anyone answered 12b? 12b, yes sir. Solve it directly by adding charges which is given in the option. That is also possible. See, if you just do that, 4 plus 4 is 8, 6 plus 2 is also 8, 5 plus 3 is 8, but if you just multiply it, that is one of the option is that this is a state. Now in case you have short in time, what you can check is that this number 12. Okay, now how can you get the 12? Now that is only happening here because the distance given here 3 meter, that is basically 3 square. 3 square is 9 and these two 9s are getting cancelled. That is why you think, okay, 6 into 2 is 12. So maybe 6 into 2 is 12 is correct. But if they give this value to be say 1 meter, okay, or if they give this value to be 6 meter or any other value, then you cannot use that same logic here. Okay, you either or you have to multiply and calculate for each individual cases. Okay, so be careful. The trick is because this is 9, this is also 3 square is 9, they are getting cancelled. So in that case 2 into 6 12 is matching. But if this is not happening here, so when you are applying some shortcuts in your mind, you have to be careful that why this shortcut is applicable for this problem but may not be applicable universally. Okay, so this is just to clear your mind. Yes, distance is cancelling the constant, that is why multiplication is giving you some idea about what is the correct option. So just to be clear that if we have not solved it in a longer way, you may not be able to understand why the multiplication is getting like this. Okay, now I can give you a better suggestion if you want, that after you have achieved this, that is x into 8 minus x. So this is two charges, right? One charge is q1, one is q2. So q1 q2 is 12. So once you reach up to this stage, then you can apply. Okay, so we have to find two charges whose multiplication is 12. Okay, so q1 q2 equals to 12. So basically what we have to do, we have to find two charges. If you multiply them, we should get 12. So this is a way after this stage, but you have to solve at least up to this stage. Without solving this, this is the proper way, longer way obviously, and this is the shorter way. After you achieved here, then you can inspect, okay, if there is a particular pair here which is giving me this answer, right? You add them, addition should be equals to 8 and multiplication should be equals to 12. There will be only possibly one option. Okay, now if they give you plus and minus, then also there is one way is that if you add them, if it is matching or not. If it is not matching, definitely that is not the answer, right? But up to this stage you have to do it. You cannot just simply multiply and solve it. Okay, Now let's see, and in case you have some time you can even expand the answer. Electric field due to infinite straight uniformly charged wire varies with distance as. So uniformly charged wire, this is from KCET 2021. So just to give you an idea, KCET questions are not always super hard, some easy questions are also there. Okay, I have mentioned 30 seconds, but it will be only 10 seconds. Okay, this will be maximum 10 seconds. So what is the formula? It depends on lambda by r. Okay, there is a constant here, but it depends on lambda by r. So it is basically proportional to 1 by r. Let's see how many of you have answered. Yes, short. Yes, short. Shabia, Srigauri. Right. Now let's move on to the next question. Question number 14. 3-point charges are placed at the corners of an equilateral triangle. Assuming only electrostatic forces are acting. So what they have said, we have an equilateral triangle. Okay, 3 charges are kept. 3 charges are placed at the corners of an equilateral triangle. Assuming only electrostatic forces are acting, the system will be in equilibrium if the charges rotate about the center of the triangle. The system can never be in equilibrium. The system will be in equilibrium if the charges have the same magnitude but different signs. The system will be in equilibrium if the charges have different magnitude and different signs. Let's see. Suppose this charge is Q1, this is Q2, this is Q3. Okay, system is in equilibrium means net force on all the individual charges will be 0. Okay, so first we have to consider, say, Q1 charge. What is the force between Q1 and Q2? Q1 and Q2 will be, force is in this direction. Q1 and Q3, it is in this direction. Okay, now if you rotate it, can we add one more force? Yes, possibly centripetal force can be acting if it is rotating around the centroid, about the center of the triangle, then the centripetal force will be in this direction. The centripetal force will be in this direction, but can it create any equilibrium? Can it create any equilibrium? Possibly no, right? Similarly here also the force, it can be both of them, suppose they are opposite charges, one is positive, one is negative, then in that case can it create equilibrium? Yes, they can create equilibrium, but in the option they have not mentioned anything about charges are positive and opposite signs and they are rotating. Okay, and opposite sign does not mean, suppose this is positive, this is negative, then this is also positive. Now this charge may be attaining equilibrium, but what about the other two charges? This will experience as a force in this direction, this will experience as a force in this direction, and in case they are rotating you will get a centripetal force in this direction. So definitely again no equilibrium is possible. Similarly for this charge also, it is experiences a force in this direction, this is experiences a force in this direction. Even if they are rotating, if they are opposite charges, does not matter, you cannot create an equilibrium with 3 charges in the triangle. So equilibrium is not possible when charges are if the charges are kept in an equilateral triangle. If it is a rectangle, if it is a rectangular shape, yes, equilibrium is possible, but for triangular shape equilibrium is not possible. Okay, the system can never be in equilibrium, that is option B. 14B. Why short you are saying 14C? System will be in equilibrium if the charges have the same magnitude but different signs. Different signs also we have seen, no. Different signs we have seen, only one charge can have different sign. How many signs are there? 2 signs are there, they are triangle, right? So you can find equilibrium for maybe one of the charges. You can find equilibrium for maybe one of the charges, but all 3 charges can never be in equilibrium. Even if it is rotating, you cannot have equilibrium for 3 charges. Now next question, 2-point charges plus 2 coulomb and plus 6 coulomb repel each other with their force of 12 Newton. If a charge, so this is the question which from previous question where we have solved it. So, they have already given you the part where initial part. If a charge of minus 2 coulomb is given to each of these charges, what will be the force now? Now, that is a easy question, not even 10 minutes, 1 minute is not required to solve. In my opinion, max to max 30 seconds you should take to answer this question. Okay. Sir, schedule, okay, I will ask Aishwarya ma'am, she will be posting the schedule in our WhatsApp channel today. Just after my lecture is over, it will be published in our WhatsApp channel for the this week's schedule at least. Okay. There was some delay because Jasmine ma'am was not available, she came today. So, from now on Jasmine ma'am's lecture will be added. So, once it is done, we will publish the schedule today. Okay, do not worry. Now, easy question 15A, 15A, anyone else 15A. Yes. So, easy question. Why I am saying easy question? Because you are seeing that okay, 2 coulomb, 6 coulomb, 12 Newton, similar figures, but what will be the new force? You have added minus 2 coulomb to each of the charges. Minus 2 coulomb to each of the charges means this plus 2 coulomb is now 0. So, plus 2 coulomb is 0, the 6 coulomb is plus 4. So, no matter whatever is the charge of the other charge, because one of the charge is now 0, the net force will be obviously 0. So, net force will be 0, right. So, this is a easy question. If you have understood the essence of the question, you do not need to do any mathematics, you can simply answer. Now, again at KCET 2021 question, a copper rod AB of length L is rotated about end A with a constant angular velocity omega. The electric field at a distance x from the axis of rotation is. So, a copper rod, I think it is a charged copper rod. Oh, no, normal copper rod. We have a copper rod, it is being rotated with one end, okay, with constant angular velocity omega. Angular velocity, it is rotated about one axis, constant angular velocity is omega, okay. The length is given L, okay. What is the electric field at a distance x from the axis of rotation? So, suppose I say that axis of rotation is x, what is the electric field at the distance from x, okay. So, you have to find the electric field here. Shravya is saying 16A, short shade is saying 16A. Let us see. Can you elaborate why it is 16A you are saying? F equals to E by M, okay. So, you are saying that F equals to E by M. So, what is the force here? This is centripetal force. Centripetal force is M omega square by x. So, we are saying at a distance x. Okay. So, at a distance x means centripetal force is m omega square by x, and it will be E E by m, right. So, electric field will be sorry, it is m square by r, I am confusing, it is m omega square x, sorry, yes, m omega square into x. Okay, this is a centripetal force. So, what we have to understand that electrons which is rotating along with the copper rod, they are producing the electric field here. Okay, and we know that force, relationship between force and the electric field is, force is basically E into E, not E into E by m. Why you have you are considering m here? M will not be here, that is the acceleration. So, force is basically E into E. So, when you are saying that okay, electrons are rotating, so what is the force acting on that electron? The only force that is acting on the electron is the centripetal force. Now, who will provide that centripetal force? Centripetal force has to be provided by someone. Only other force that can other thing that can provide the centripetal force is the force on the charge due to the electric field, that is E into E. So, this is compulsory. Now, from here you can calculate electric field E is equal to m omega square x by E. So, maybe you remember the answer, but while executing you may have forgotten it. So, yes, most of the students have said the correct answer, option A. So, you have to remember that a rotating rod will have a electric field because there is a centripetal force as well as electric force. Now, if you compare them, yes, F is equal to E E. Yes. 16 no, 16C no is not answer. It is option A. Option A. Right? I have solved it, and then you are answering it wrong. Anyway, good try. Anyway, I do not discourage you even if you are solving it incorrect. The only thing that you have to realize what mistakes you made. Okay, if you can correct that, that is great for your preparation. Now, we have 7 more minutes and I have to solve 3 questions quickly. The electric field lines on the left have twice the separation on those on the right as shown in the figure. If the magnitude of field, this is I think slightly mistaken, electric field is volt per meter. Okay. So, volt per meter, unit is given in volt per meter. Magnitude of the electric field at A is given 40 volt per meter. What is the force on 20 microcoulomb charge kept at B? So, that is a interesting question. So, here we have kept 20 microcoulomb, okay, and here the electric field is given 40 volt per meter. Okay. What is the force on this 20 microcoulomb charge? First, what you have to do, you have to find the electric field here. Okay, you have to find the electric field here. If you can find the electric field here, you can find the force. Okay, force is easy. Force is basically Q into E. Okay. Now, what is the electric field at point B? That is the main question. And it is given that it is twice, the electric field lines are twice packed here compared to here, right? Twice the separation. The separation, if this separation is say this separation say x, then this is 2x. Okay. So, what is the force? 17C. Let us see. So, first of all, we have to find the electric field. Electric field, more the separation, less is the electric field, they are proportional to the separation. So, concentric, more concentrated electric field lines means electric field is more, elongated electric field lines mean electric field is less, and it is directly proportional to the separation, right. So, electric field at point B is basically, because it is twice distance apart, it will be 20 microcoulomb times the electric field will be half of that. So, electric field will be half of that. So, you have to divide with this factor, do not multiply it. So, be careful, you cannot multiply it, you have to divide it. So, it will be 20. So 20 into 20 is 400 into 10 to the power of minus 6. So it will be 4 into 10 to the power of minus 4. So correct answer is 4 into 10 to the power of minus 4. Most of you have answered it correctly. Yes, yes, haha, you are correct. Pooja is correct, right? FB is equal to QEB. Yes, that is also possible. Next question, question number 18, another KCET question. A certain charge Q, 2Q is divided first into two parts Q1 and Q2. Later the charges are placed at a certain distance. If the force of interaction between the two charges is maximum, then what is the ratio of Q by Q1? We have solved one similar question, but this question is slightly trickier than that one. Okay, so you have to solve it. So we have separated two charges Q1 and Q2, and it is given basically equals to capital Q. Okay, now they are placed at a certain distance, so certain distance d. Distance is obviously not important here. They are placed at certain distance d, Q1, Q2. Okay, and it is said that the force is between them is maximum. What is the force? Force is basically K Q1 Q2 by d square. Now this is maximum. If this is maximum, what is the ratio of Q1 by Q2? Very interesting. Q by Q1, sorry. What is the ratio of Q by Q1? Pooja is saying 18A. (18x). Gautami is saying 18A, Stravya is saying 18C, Haha is saying 18B. Okay. See, let's see. We can do the mathematical way. We can differentiate it. We can find the maximum condition, but that will be a very long solution. First of all, you have to replace it Q1 with here. Then you have to differentiate with respect to Q1. Then try to solve it. That will be a very long case. But what we can do is that we can use this fact that what we are trying to find. We are trying to find this ratio is 2Q. What we are trying to find? We are trying to find the ratio of Q1, Q by Q1. Now, if this is equals to 1, that means we can easily do it. So, force is Q1 is equal to Q. So, the force will be equals to Q2 will also be Q. Both of the charges will be equal in that case. So, it will be K Q square by D square. Okay. Now, let us see the second case. Second case, it is saying that B is equals to 4. So, Q by small q equals to 4. So, in that case small q will be equals to Q by 4. So, Q by 4 means Q2 will be equals to 2Q minus Q by 4. So, that will be 7Q by 4. Now, what is the multiplication? So, if you do the multiplication, you will get 7Q square divided by 16. Okay, which is definitely not as big as Q. Okay, so you are getting a lesser fraction compared to this. Okay, so you have to remember that whenever you are trying to separate two charges, the hi Vinay, welcome. You missed the entire lecture almost. Okay, so you have to remember that when you are dividing a charge into two parts, so that the force between them is maximum, the two parts should be equal. In that case, the force will be maximum. If the charges are divided into two equal parts, then only the force between them is maximum. That is the shortcut. So, in this case, because you are separating 2Q, the two charges, both of them should be equals to Q only. So, the ratio of Q by Q1 should be equals to 1. You can check with other options as well. So, if you are choosing C, option C, that means one of the charge is 2Q, other charge is completely 0, force will be 0. you can check with this answer also. You will get always the in any other case the answer will be a fraction. Okay. There is a mathematical way to solve this question as well, to prove that if it was a theoretical question for your board exam, maybe prove that when the charges are equal the forces are maximum. So, in that case you have to do the mathematics, otherwise we are smart, we will not waste too much time in such questions. Okay. Now, another KCET question, KCET 2018 question, the magnitude of point charge due to which the electric field 30 semi away has a magnitude of 2 Newton per coulomb will be. Another easy question, last two questions will be slightly easy. Sorry, very late. Pooja, 18A sir. Yes, 18A is the answer. Let me say 18D. Short sir, you can try with 18D and check, right. So, you have to be careful whenever they asked you when the force will be maximum. Force will be maximum when the charges are separated by 2 equal amount. Now, the magnitude of point charge. So, what we have given, we are given basically electric field due to a point charge. So, KQ by R square, easy question. Okay. Only the thing is that this is a 30 centimeter. 30 centimeter is basically equals to 30 into 10 to the power of minus 2. Now, let me know how you are comfortable with this. Are you comfortable with decimals, putting decimals, or you are comfortable with doing like this? I prefer to do it like this because I am very comfortable with 10 to the powers. Okay, because when I used to solve using decimals, I was always confused where I have to put the zeros when I was a student. So, later on I figured out if I use 10 to the powers, it actually helps me a lot. I do not get confused. Okay, square, if I am doing square, whether I have to put 1 0 or 2 0 or 3 zeros or 4 zeros. So, that was very confusing for me. So, later on I started using this and all my problems are gone. So, I suggest that to a student as well, but in case if you are comfortable using decimals also, you are welcome, no problem. So, 3 into 10 to the power of minus 1 whole square, and electric field is given 2 Newton per coulomb. So, again this is not 9, okay, this is Q. So, 9, let us solve 9 into 10 to the power of 9 into Q divided by 9 into 10 to the power of minus 2, okay, cancels. So, you get this as so Q into 10 to the power of 11 becomes my 2. So, Q is basically 2 into 10 to the power of minus 11 coulomb. Okay. So, option A is the answer. Now, let us see who has answered correctly. Yes, Pooja correct, Haha correct, but Haha always mention the question number. Pooja Jadhav, yes, 19A, Sneha 19A, Pratiksha 19A. Yes, 19A is the correct answer. Okay. So, we have solved a lot of questions. This is another question, slightly medium. An electron of mass m, charge E, falls through a distance h meter in an uniform electric field, then the time of fall. Okay. Another interesting question. So, you have some electric field, suppose electric field is like this. You have dropped an electron, electron is moving, okay, but there is no gravity, okay, gravity is missing. Electron falling means gravity is not there, electron is moving opposite to the electric field, okay. So, electron is moving in the electric field. After some time t, it moved say a distance h, it moved a distance or it falls a distance h, then what is the value of this t? Okay. 20A, Shravya is saying 20A, Short is saying 20A. Let us see. So, first of all you have to remember that only way to solve it, you have to calculate the acceleration. If you can calculate the acceleration, okay, you know that the formula is h is equal to half at square, that is the formula, okay. So, if you calculate the acceleration, t will be equals to 2h by a square root, Okay. Now, so one thing is sure that definitely this is not possible, this is not possible, this is also not possible. Okay. Even if you have not calculated the acceleration, you know that the answer should have a square root of h. So, only one way the square root of h is possible, that is the option A. So, option A is the correct answer. In case they give you other options with square root of h, then you have to check with acceleration. What is the acceleration here? Acceleration is force divided by mass. Force is charge of an electron into the electric field divided by mass, right. So, you have to put this here and you will get 2 hm. This m is in division, so it will go up, right, and E into E will stay in the division and there is a square root. Okay. So, definitely this is the answer. Okay. So, easy. The shortcut way to solve this just by remembering this formula from your PU1 and realizing that there has to be a square root of 2h. So, from the options given, square root of 2h is present in only one. So, that will be the answer, and if you want to be sure, you have to calculate the acceleration from the fact that it is basically force by mass. So, from there you can calculate it. Okay. So, I hope you enjoyed this session, right. Yes, yes, s equal to ut plus half at square. Generally for accelerated motion, we already remove the ut part. Okay, we only remove the half gt square. For example, when we drop one ball is falling. So, when as soon as the ball is falling, that means half gt square, right. So, half gt square, we already know that electron is falling means it will be half at square. You just need to calculate the acceleration. Okay. So, today's lecture is over. But tomorrow 9 am I will be here. I will be giving another lecture on electrostatic potential and capacitance, and I don't think I will have any other live this week. Next week, whenever I am coming live, I will be talking about 2 chapters. Okay, electrostatic potential and capacitance as well as electric current. Both chapters will be covered by then. So, be prepared and be ready. More questions we will practice from those 2 chapters, and we will discuss more misconception that you might have. With this note, I will end this lecture. If you have any questions, please give me ask quickly. U is 0 because of free fall. Yes, 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 Kirti and Shravya. For free fall cases, always we take U is equal to 0, right. So, that is the things that you have to be careful about. Okay. So, if you don't have any question, I can close this session. Right, I have to record tomorrow's class as well. I have not recorded tomorrow's class yet. So, that will be a recorded format, but you will get that class at 9 am, right. Okay. Thank you everyone. I will be